Today's lesson is an 8th grade lesson. We are in Unit 1, Lesson 5, and this is about getting equations when the answer is interesting and it's going to end up telling you that there's either no solution to the equation or infinite solutions. So today's examples are all going to be, they're going to start out as variables on both sides, but this could happen with any kind of equation with distributive property, combining like terms, any type of situation. If you were ever to get a certain type of answer, it's more of the answer that we're looking for these types of equations rather than looking specifically at like what the question looks like when we start. So let's go ahead and do our first example. So our first example, it tells us that there's going to be no solution, but when you're actually performing these problems, it's not going to ever tell you that the answer is no solution. I just wanted to make sure I explain that before we go through this. So when you look at this question, it just looks like a distributive property with variables on both sides. So we're going to solve this problem the way we would any problem. So I'm going to start out by placing my wall down the center. And then I'm going to analyze what I've got. So on the left side, I've got -4 times a parentheses. And on the other side, I just have two terms. So I know that because of PEMDAS, I'm going to get rid of those parentheses first. So I would need to distribute. There I've drawn my my distributive cherry bomb, as we like to call it. So now I'm going to go ahead and multiply. So I'm going to multiply -4 times +2x, which is going to give me a -8x. And then I'm going to do -4 times +1, which gives me a -4. And on the other side of the equal sign, I'll just bring down -8x minus 2. So as I said before, we just started this problem out exactly as we would have if it didn't tell us that the answer is no solution, because I want you to see what it looks like when we have a no solution. Now let's look at the terms that we're left with. So on the left side, I have a -8x and a -4, which doesn't have an x on it. So that's a different term. And then on the other side, on the right side, I've got a -8x and another term that is a -2. But since these two variable terms both have a positive x, I'm going to go ahead and attempt to combine those by moving one of them to the other side. So if I want to move either of them, because they're both -8x, to the other side of the equation, I would need to do the inverse operation. So the inverse operation is to add 8x because it's a -8x. So let's go ahead and add 8x to both sides, because if we do it to one side, we're going to have to do it to both sides. So plus 8x over here and plus 8x over here to keep it balanced. This is going to cancel this one out, and we're left on the left side with a -4. But on the right side, you're also going to see a -8x plus an 8x is actually going to cancel out also. So all that's left on this side is -2. So when we get an answer like this that says -4 is equal to -2, when you think about that, hopefully your brain's saying that's not true. -4 is not the same thing as -2, which is correct. So that means that there's no solution. When you have an answer that makes a statement or expresses a statement that is completely not true, and you're going to be like, nope, that's not true, -4 does not equal -2, the way that we would interpret that in mathematics is to call that a no solution problem. So again, I want to tell you that at the beginning, the problem just looks like an ordinary problem that we might be asked to solve. But in the end, you can see that it's a no solution because we end up creating a statement that is not true. It doesn't express something that's true.